All right, guys, we're going to get into the last unit of this course, which is going to be Unit 10, Groove Welds. So, home stretch. Um, we're going to skip over some of the stuff that we covered in the fillet weld last unit, since there's a lot of similarities. It's just going to be more of a focus on this one on the groove weld symbols, which there are a lot more of, but pretty easy to kind of get familiar with them. So some things from the previous unit, we should have a very good understanding of some common things in a weld symbol. One is going to be the weld contour symbol. Remember, we got three: flat, convex, and concave. Flat to slightly convex is what you're going to be shooting for with like most of your welds. We'll have concave welds a lot of times when we're doing like downhill welding, things like that, certain open root butt joints, depending on the process. But for the most part, a flat to slightly convex weld is what we're shooting for. The three common components of a fillet weld profile, which if you're in 2A, 2B, you should have this memorized at this point: the face of the weld, the toes of the weld, and the throat of the weld. All right, the face being what you're looking at for the most part. The toes, that's where the base material meets the weld material. That's where we get things like undercut and cold lap. And then the throat is just how thick the depth of that weld from the root to the face. Okay, so let's get into groove welds. For this unit, we'll be going over the different types of groove weld symbols, how to interpret all the information. There's going to be a little more that goes along with groove welds, like the root opening, the groove angles, things like that. We'll still have certain symbols like contour and finishing symbols that are going to be the same, and we'll have a kind of a different terminology for the weld profile. So once again, the whole welding symbol. This is a really good slide to download just as a cheat sheet kind of. Depending on the weld symbol, you may or may not have all of this. Again, like length of weld and pitch, it's really only going to be on intermittent welds. Groove angle, groove weld size, you're only going to have that on a groove weld. So you're not always going to have all of this on there, but this is a really good cheat sheet for you to keep with you. Okay, so groove weld nomenclature. Nomenclature is just a fancy way of saying terminology. All right, so very similar to a fillet weld profile, same terminology. We still have our toes, we still have our face, just looks a little different, okay? But we're gonna go over the throat, the effective throat and actual throat. So the effective throat is basically the amount of penetration that you want. So really that's just gonna be the measurement, the thickness of the material. That would be the effective throat. But the actual throat is what you get with the reinforcement, whether it's on one side or both sides. Because now on groove welds, we don't just have reinforcement on the face. If it's an open root, you're going to have reinforcement down at the root as well. And so that discontinuity that we've talked about, excessive reinforcement when you got too much buildup, well, now you might have that on the back side as well. So effective throat is going to be the weld material through the cross section of the base material. The actual throat, which you get after you have that weld, is going to include reinforcement, and that's face and root reinforcement. Okay, so PJP, that just stands for partial joint penetration. What we're looking at right here is actually CJP, that's complete joint penetration. So we can see we've got weld material all the way through and sticking out both sides of this workpiece. Partial joint penetration would be if it was calling not for full root penetration. And sometimes you might have that called, and then you would do a back weld on the other side of it, where your backing bar may have been. So PJP, partial joint penetration, and then there's also CJP, complete joint penetration. There's that same terminology we just went over. All right, so here's another slide that would be good to download. This has all the common groove weld symbols. Again, you don't need to remember all this stuff. You just gotta kind of have an idea and have these charts, things like this, readily available. And so this is the part where I'm telling you, when it comes to the groove welds, the weld symbol itself looks more like the fit up of the workpiece, right? So a square groove weld, it's just imagine you got two 1/4-inch coupons and you butted them up together, okay? If you the gap, the groove between those welds looks like two parallel lines. Single bevel, single bevel. Single V looks like a V. So you kind of get an idea and you can familiarize yourself. U groove, it would be gouged out like a U. A flare looks like it's just got a radius to it. Same thing there. Double flare, same thing. Think about like two pieces of round tubing butted up against each other. So an easy way to remember groove symbols is the welding symbol looks like the joint after it's been prepped, or just from its kind of natural shape. So square groove welds, probably the most common, require little to no joint prep, maybe just cleaning, but usually you're just butting up two already sheared off pieces of material. And so just think about like in 2B, you've got a couple stainless welds, a stainless TIG butt joint on the purge block, and then your stainless MIG. Those would be square grooves because you're not doing any sort of beveling. There's no radius to those coupons, so they're just parallel. Bevel groove welds, if you're going into 4A, this is pretty much all you're going to be doing. Single and double, depending on the qualification that you're going for. Actually, I think all of you guys are going to be doing V grooves. So single bevel grooves, when a material gets to about 3/16 or thicker, remember that's where plate begins, it's usually recommended that you give it a bevel just to increase that fusion zone on the weld. And then once we get up to the even thicker plate, 3/8 and thicker, usually they're asking for a double bevel groove if it can be done from both sides. Obviously, if you can't reach the other side of that plate, it's kind of redundant to bevel it, but to compensate, you might give like a steeper taper to the bevel, like a 45-degree angle, and bring that taper back so that you have more groove to fill in. Okay, so we should all know arrow side and other sides. I can't remember if we went over this in Unit 9 or not, but when you have a break in the arrow like that, okay, that's telling you which coupon, which plate to put it on, right? So we've got a break pointing at A. So we want the bevel on plate A, all right? And again, down here, we have a break in the arrow and it's pointing to the coupon that needs to get the prep work. All right, so when you see a little break in the arrow like that, that's telling you which side or which piece of material to prep to put the groove on. Okay, V grooves. So I think we are all familiar with what a V groove looks like. Pardon my drawing. All right, so when you've got a bevel, a single bevel on both sides of the coupons, and they meet together making that V shape, that's going to be your V groove. And then we have a J groove, so just a different alternative to a bevel groove. A J groove is going to have more of a radius to the material removed, like you can see right there. Okay, but we still have a flat landing kind of towards the root when it's a single. So this is one of those processes you might see carbon arc gouging used on to bevel to give that radius on one coupon. That's one of those things that can be done out in the field using that Kaka method. And this is the profile of a J groove. And again, over here, we see that break in the arrow. It's telling us to prep side A. Okay, so the root opening is simply the space, the measurement from root face to root face, okay, or landing to landing. All right. Here's a great example of it. So this is telling us we need a 1/16 inch gap for this square butt. Okay, and that's what it would look like, just a 1/16 gap. If we had a V groove and it wanted an 1/8 inch gap, then this flat spot at the root, okay, that's what we would call the landing, would need to be an 1/8 inch gap. You're not going over the face, it's got to be by the root. And again, double square. 1/8 inch gap, 1/8 inch gap, and same thing over here, double V, so we got a V on both sides, and at the point, the shortest point, which would be the root, it's going to be a 1/16 inch gap. Okay, so the groove angle, so obviously this needs to be denoted so you know how to prep the material at what angle. Not all weld qualifications are going to require the same bevel angle. It depends on the qualification itself, depends on the code. All right, so again, if we had a V groove, we would have the root opening, and then above that would be the bevel angle. And that is the entire angle, okay? So you would not set your torch angle or your grinding angle at a 45. You would have to, this needs to be a 45-degree opening, okay? That means you would draw a line down the center and you would split it in half. So you would be doing like a 22.5 bevel and a 22.5 bevel to get a 45-degree V opening, all right? U groove, same thing. 16th inch gap, boom, boom, 30-degree and 45-degree. Remember our hour side and other side. Now we have groove depth. So this is the distance from the surface of the base material to where the removal of the base material for the groove stops. Okay, and so most of the time we have an open root, we're going to have that flat spot. That's the landing. Okay, and that's where the groove depth comes in place. Okay, so right here, 16th inch gap, 45-degree bevel, 3/8, which you see right here. Okay, so that's how deep it goes before we hit that landing, that flat spot between the root faces. Once again, arrow broken, so we're prepping that side. We've got a double bevel, 35-degree, 35-degree, 16th inch root, and a 3/16 depth. Okay, again, just going down to the root, to the landing. Okay, then you have your groove weld size. So sometimes the size of the weld does not need to be the thickness of the base material. Just like a good example would be a square groove. If we're doing like some 10 gauge, okay, obviously you're gonna be hard pressed getting a bead as thin as some 10 gauge. And so the weld is going to be bigger. Sometimes it's going to be smaller. So the groove weld size is indicated to the left of the weld symbol, the groove weld symbol. Okay, so 3/16, that's telling us we want that 3/16 depth. Okay, so different than the fillet welds. Okay, so groove weld size is 1/4 inch, so it's saying it needs 1/4 inch penetration. Just remember on a fillet weld, if it's to the left, that's the leg length that we're looking for, but for a groove weld, depth. Okay, melt through. So if you've got something like backing strip or a material behind, that won't apply. Melt through is only for CJP, okay, open root grooves, where you need full penetration all the way to the other side. So melt through is going to be this darkened symbol. That's telling you 60-degree opening, so that'd be 30-degree bevel and a 30-degree bevel. And then we're looking for what's that finish symbol, that face symbol? It's going to be a convex weld with melt through. So we need to have a certain amount of reinforcement through the root. Then we'll have a different symbol for a backing bar. So sometimes you won't have open root, you'll have a backing bar. So this is to help reinforce the root as you're welding it up. And this is going to be that symbol right there. Okay, it just looks kind of like a piece of backing bar almost. Again, just kind of mimicking what the fitment actually looks like. So if the backing strip is to be removed, there will be an R there, and that means that after the weld is completed, the backing bar must be removed. If there is no R, then it can stay. And again, 45-degree opening, 3/16 root opening with a backing bar. Okay, and so when you run your root, you'd be fusing into that backing bar, and this is really just to make sure that you're bridging the gap between the root faces. Okay, so this is always going to be placed backing weld. Okay, so this is different than a backing bar. So a backing weld, this is placed on the root side of the joint before the rest of the weld is placed. So imagine you didn't have the backing bar there, and you got everything prepped up, tacked together. You would weld the root side, so the back side of that joint, and then you would go and fill in that groove. Okay, so this is just another way to allow CJP, complete joint penetration. So you would come in, prep it, there's your groove. You would go and weld this from the back side, and then you would come through, and that would be kind of acting like that backing strip. Okay, so it'd be your reinforcement for the root, and then you would continue on as normal on the front side of that groove. And then you have a back weld. So this is done just like the backing weld, but a back weld is done after the welds. Okay, so you would come in, prep your material according to the drawing, so another V groove with back weld. Okay, so you would come in and you would do your weld, and you would have a groove where the root would be. So after you're done filling in all the intermittent and face cap welds, you would then come back and fill that in on its own. Obviously, this is only going to be in applications where you have access to the backside, which is actually can be pretty rare out in the industry sometimes. But that is the difference between backing and back weld. A back weld is done after, and a backing weld is done beforehand. And the back gouging, so sometimes you'll run a double bevel just like this. You'll come in and weld one side, and then you'll back gouge before you come in and lay the other side, just to make sure that those roots are getting completely fused. Then we have spacers. Okay, so material over 1 inch thick is generally welded with some type of groove weld. When the joint is welded from the first side, the spacer is consumed. So there are consumable spacers and non-consumable spacers. A consumable spacer, imagine you're welding 20-foot beams together, parallel with each other. Okay, there's going to be a lot of distortion and warpage as you're going along. So those the spacers, they'll be put inside those beams, and they will just get consumed with the weld. Obviously, if it's not meant to be consumed, it would be denoted, and that would have to be removed before the welds were done over it. And this just looks like a rectangle. Okay, so the spacer size and material, 1/8 inch by 3/16, and that's just the material type, 1020. Okay, so that's telling me I need an 1/8 inch by 3/16 spacer in that weld, and that's just to keep those grooves open and consistent. Because again, when we're talking welds, we're talking symmetry. We want to minimize how much that groove is going to open or close as we weld, as metal moves a lot when you've got really long pieces and you're adding a lot of heat in there. And then consumable insert. Okay, so this is used to improve fit up. Again, kind of like a spacer. This is meant to be a lot of times as like an additive material, and this looks more like a square than a rectangle. And the primary difference between a spacer and a consumable is a consumable insert is fully consumed as a part of the weld. Sometimes spacers get welded in there, but they're all fused around it. But this should be melted into the puddle, so it's fully consumed. Whereas a spacer is sometimes fused to or removed. This one gets added completely. Just think about if you were gapping like a TIG butt weld with some filler rod. As you were welding, you would want that filler rod to be fully consumed into that puddle. Whereas the spacer is more like a little extra joint in there that's getting fused at the toes. All right, guys, that's the end of this unit. We'll see you on the next one.